In today's class, we're going to talk about Newton's laws of motion. There are three Newton's laws of motion. Okay, let's start with the first law. The Newton's first laws of motion state that an object at rest will remain at rest unless acted upon by a force. You can put that down. An object at rest will remain at rest unless acted upon by a force. Okay, an object in motion will continue in motion unless acted upon by a net force. You can see now those are the two parts. Those two are the first Newton laws of motion. You understand? I just divide it into two parts. Okay, the first part is that an object at rest will remain at rest unless acted upon by a force. Okay, let me explain that. Let's say I have a table. Please, I want you to pay attention. Let's say I have a table here. This is a table. Okay? I have a box on this table. You understand? This box will not move unless it is acted upon by a force. Okay? There is a force that is currently acting on this box. That force is weight force. We have the weight force. You can put that. You can write it down. Weight force. Weight force is currently acting on this force. What weight force does is that it exerts a downward force on that force, on that box, you understand, such that that box remain at that position, you understand. But the box will not remain on this position if there is no another force that is acting on the box. Please, I want you to understand. There are forces that is currently acting on this box. The first force is the weight force. Do you understand? The other force is the normal force. Let me put it down. The normal force. Okay, what I'm trying to say is that the weight force is a downward force. You understand? The weight force is is like the force of gravity. You understand? It's like a gravitational force that causes an object to move downward. You understand what I'm saying? So the weight force is acting upon this box, and there is another force that is keeping this box to be balanced. That force is what? The normal force. The normal force is the force that this table exerts on this box to make it balanced. You understand? You know, for an object to be a stationary point, the net force of that object must be equal to what? 0. Do you understand? That is a balanced force. The force must be balanced. So now let's say the force, it has a mass of 10 kg, and we want to calculate the weight force. The weight force is given by this formula. Weight force is equal to mass times acceleration due to gravity. Do you understand? Okay, so for this I'm going to have mass is what? 10 multiplied by 9.8. Let me use 9.8. That is what? 98 Newton. So the weight force of this box is what? 98 Newton. Now, you know that I told you this box is a stationary point. That is, the box is not moving at all. So we can get the normal force. The normal force is the force that is opposite the weight force. That is the force that keeps the box on the ground. That is the force that the table exerts on this box. So the normal force is also the what? 98 Newton. So the sum of all the force acting on this box is what? 0. Do you understand? Because the weight force is acting in this direction and the normal force is acting, the weight force is acting in this direction and the normal force is acting, the normal force. This is the weight force, okay? The weight force is acting in this direction and the normal force is acting in this direction. So to make the box balance on this table, that means 98 Newton is the normal force and the weight force is also what? 98 Newton. So therefore 98 Newton minus 98 Newton, that is what? 0. Do you understand? Because we have two forces acting in an opposite direction. Okay? Now, that is the first part. In order to displace this object from this position, okay, in order to make this object change position, there will be another force that I'm going to apply on this object to counterpart the balance force. You understand? If the force is still balanced, okay, that means the object will remain at that position. But if I apply another force that will make these two forces imbalance, then the object will change position. Do you understand? That's justified Newton's first laws of motion. An object at rest will remain at rest unless acted upon by a force. Do you understand it now? Okay, let's proceed to the second part. An object in motion will continue in motion unless acted upon by a force. Okay, let's say I have a surface. Let's say I have this surface. Then I roll a ball. I roll a ball in this direction. Let's say I have another surface, a rough surface now. I have a rough surface. I roll this ball in the same direction. Now, let me ask you, which of these balls will cover a large distance? Of course, this is the ball that will cover a long distance. The reason is because this is a rough surface and this is what? A smooth surface. Now, if this ball is rolled on a rough surface, you can see that there will be a lot of friction between this ball and this surface. Do you understand? So therefore, as the ball moves, the friction, and don't forget that friction opposes motion. You understand? Friction is a force that opposes motion. So as the motion of the ball tends to move, as the ball moves, the frictional force will oppose the motion. In that state, the ball will not cover a long distance. But compare this surface to this surface. This ball will cover a distance before it comes to rest. And apart from frictional force, I want you to know that there is another force. There is also air resistance. You understand what I'm saying? There is air resistance that is acting on this box, because there is nowhere we can actually find a place in let's say on this earth. There is nowhere we can actually find a place whereby there is no force that will counterpart an object that is in motion. You understand? That only happens in space. That is outside earth. You understand? So for example, now this doesn't mean that this ball will not come to rest. It will come to rest because there is air resistance. Okay, air resistance. Apart from the air resistance, apart from the frictional force, there is also air resistance that will bring the object in motion to rest. But let's say we find a way of removing the frictional force and there is no air resistance, the object will continue to move. And a typical example is the movement of the earth around the sun. You know, we have the sun here and we have the earth. The earth continue to orbit the sun. You know, till this point, the earth is still orbiting the sun. Why is that so? It is because there is no friction, or in space there is virtually no friction that can oppose the motion of the earth. You understand? So the earth continues to orbit the sun. Let me call this sun, and this is earth. Okay, so an object in motion will continue in motion unless acted upon by a net force. That is the Newton's second laws of motion. It is important to know that even though there is no frictional force that opposes the motion of the ball, that is the first ball, there is also air resistance. You understand? On this earth, you know, there is nowhere we can actually find a place whereby there is no resistance to an object in motion. It is very, very important that you know that. Okay, now how can we apply this? There are two things that I want you to note. Okay, if an object is at rest, the net force is equals to 0. That is the first point. Okay, if an object is at rest, the net force is equals to 0. And if an object is in motion, let's say the object is moving at a constant velocity. Let's say an object is moving at a constant velocity. Now, if an object is moving at a constant velocity, that is, there is no acceleration. Don't forget, acceleration tells us how fast the velocity of an object is changing. Then at constant velocity, there is no acceleration. In that case, acceleration is equal to what? V minus u all over t. Do you understand? Now, for this, I'm going to have v minus u. The v here is what? The final velocity, and u is the initial velocity. Since the object is moving at a constant velocity, the initial velocity and the final velocity will be the same. Do you understand? And if the initial velocity and the final velocity is the same, let's say the object is moving at a velocity of maybe 8 meters per second. Do you understand? So for this, I'm going to have 8 minus 8 all over t. Do you understand? So acceleration is equals to 0 over t. So a is equals to what? 0. That is, acceleration is 0. You can see now. And that means that when an object is moving at a constant velocity, the force acting on that object is also what? 0. Do you understand? Please, it is very important that you note those 2 points. When an object is at rest, the net force of that object, the net force acting on that object is what? 0. So when an object is moving with a constant velocity, the net force at that the net force of that object is what? 0. Okay, as we progress to the second law of motion, we are going to delve more into this. Okay, just pay attention. Now let's proceed to the second law of motion. The Newton's second laws of motion state that the force acting on an object is the product of the mass and acceleration. Okay, this can be expressed mathematically as this: the net force is equals to the product of mass and acceleration. You can see that the net force is directly proportional to both mass and acceleration. Let's say the mass of an object is maybe 20 kilogram, and the acceleration is maybe 4 meter per second squared. Okay, now we are told to determine the net force. The net force is what? The mass, which is 20 kilogram, multiplied by acceleration, which is 4 meter per second squared. Okay, so the net force is what? 80 Newton. Is that not it? Because force is measured in Newton. Okay, now I want to pay attention. What if the acceleration is doubled and the mass is kept constant? If the acceleration is doubled, I mean the net force becomes 20 kilogram, which is for mass. If the acceleration is doubled and the mass is kept constant, so if you double the acceleration, we're going to have 8 meters per second squared. Do you understand? So I'm going to have multiplied by 8 meters per second squared. So the net force is equals to what? 20 multiplied by 8 meters per second squared. That means I'm going to have 160 Newton. So the net force is what? 160 Newton. You can see that the net force is directly proportional to the acceleration. As the acceleration increases, what happens to the net force? The net force also increases. Now let's say we tripled the mass of the object. So for this, the net force becomes 60. The net force becomes mass. The mass is tripled, so I'm going to have 60 kilogram. 60 kilogram multiplied by, and we keep the acceleration constant. So 60 kilogram multiplied by 4 meter per second squared. So the net force here will be what? 60 multiplied by 4. That is 240. So 240 Newton. Do you understand? You can see that means force, the net force, according to Newton's laws of motion, the net force acting on an object, the force acting on an object is directly proportional to the mass, the product of the mass, and acceleration of the object. Do you understand? So that's the summary of Newton's laws of motion. And also the Newton's second laws of motion, this can be used to express the relationship between the impulse and momentum of an object. Okay, don't forget that. Okay, let me just do it here. Force is equal to what? Mass is the product of mass times acceleration according to Newton's second laws of motion. Okay, and acceleration can be expressed as what? The change in velocity, that is v minus u all over t, change in t. Let me just put change. Okay, let me put change in velocity over change in time. Do you understand? Please, it is very, very important that you know this. Okay, so now let me call this equation 1, let's call this equation 2, okay? Let's call this equation 1, let's call this equation 2. Now, let me substitute the value of A as change in V over change in T as the value of acceleration in equation 1. So I'm going to have F, which is the force, is equals to mass multiplied by change in V all over change in T. Do you understand? Okay? Now, don't forget that momentum is the product of mass and velocity. Do you understand? Momentum is the product of mass and velocity. That means that, okay, let me just put it. The momentum, I just put capital letter M so that to differentiate it from this M. M, small letter m in this case is the mass of the object, and capital letter M is the momentum. Are you get what I'm saying? So momentum is mass multiplied by velocity. Velocity. So for this, momentum is equals to mass multiplied maybe change in velocity. So I can substitute the value of momentum into this equation. Okay, so I'm going to have, please, this is the equation that we are following. Okay, so force is equals to mass, which is small letter m, multiplied by big letter m. Big letter M, yeah, big letter M all over change in time. Okay, so the momentum can be expressed as change in momentum is equals to what? Mass multiplied by change in velocity. Do you understand? So the force now becomes mass multiplied by change in momentum, just like substituting change in momentum over change in time. Please, do you understand how I got here? You know, I have mass multiplied by change in velocity here, and change in velocity means there will also be change in momentum, because momentum is the product of mass and velocity. Do you understand? Okay, let's proceed. For this now, we have gotten here. If you multiply both sides by change in time, that will be force multiplied by change in time is equals to mass multiplied by change in momentum, and force multiplied by time is what? Impulse. Do you understand? Impulse is the product of force and time. Do you understand? So this will be impulse. Impulse is equals to mass multiplied by change in momentum. Mass multiplied by change in momentum. So you can see the relationship between impulse and momentum as described by the Newton's second laws of motion. Okay, so now let us proceed to the third laws of motion. Newton's third laws of motion state that for every action there is always equal but opposite reaction. This implies that if you apply a force, you are going to feel a force that is opposite to that force that you applied. Do you understand? Let's say we have a person jump on here. A person that is holding a ball jump on a here and throw a basketball. You understand? Let me just put like this. I'm not really good at drawing. You understand? Just pay attention, okay? Now, let's say this person threw this basketball. He threw it. This person apply a force. You understand? According to the Newton laws of motion, this person is actually going to felt a force that pull his back. You understand? That is what Newton's laws of motion was talking about. That is, for every action, there is always equal but opposite reaction. That means for every force exerted on an object, there is always equal but opposite force. You understand what I'm saying? That is, Fa is equals to minus Fb, because that force is acting opposite to the direction of the force that is applied. In that case, the force is acting on this person itself. You understand? So now, let me ask you a question. Let's say the mass of this ball is 2 kilograms. Okay? And the mass of the boy, the mass of the person that throws the ball, is maybe 100 kilograms. Okay? 100 kilograms. You can see that this ball is going to move, is going to cover a long distance because there is a lower mass. It has a lower mass. You understand what I'm saying? Let's say the force that the person applies is 200 Newton, okay? Let's say the force that the person applies is 200 Newton. Therefore, that means that this force will also be what? 200 Newton. Now, let's calculate the acceleration of the board. The acceleration of the board can be calculated from the Newton's second laws of motion. According to Newton's second law of motion, the force is equal to what? The product of mass and acceleration. Okay? So make acceleration the subject of the relation. We're going to have force over mass. Okay? So acceleration of the ball will be what? Acceleration of the ball will be equals to force, which is 200 Newton, all over mass. What is the mass of the ball? The mass is 2. So the acceleration is 100 meter per second. Okay? Oh, 100 meter per second squared. You understand? Okay? Now let's find the acceleration of this person that threw the ball. You know, it's going to have a negative acceleration because he moved opposite to the direction which the ball is thrown. Okay, so for this I'm going to have A is equals to what is force? The force is also the same, that is 200 Newton. You understand? All over mass. The mass of the person is 100. That is what? 2 meter per second squared. That is negative 2 meter per second squared, because the force that the person experienced as a result of throwing the ball is opposite to the force applied towards the ball. That means this force will be what? Negative. Do you understand? That means that's how I got negative 2 meter per second squared. So when an object has an higher mass, you understand? When an object has an higher mass, and another object has maybe a smaller mass, we have another object just like this ball, have a smaller mass. If both objects travel at equal acceleration, the object that has a smaller mass will travel faster. It will cover a long distance compared to the object that has an higher mass. Do you understand? So let's say you are in a space, okay, and we have the sun, we have the earth here. This is the earth, and this is the moon. You are holding a ball, okay? Let's say you are in a space, and if you want to move towards the direction of the earth, which direction are you going to throw the ball? That's my question. Let's say you are in a space, you are holding a ball. This is the earth and this is the moon. Let me call this the moon. Okay, let's say you want to throw a ball. In which direction will you throw the ball? Of course, are you going to throw the ball upward? Are you going to throw it downward? Or in the direction of the moon? Or towards the earth? In order for you to move towards the earth, in which direction will you throw the ball? Yeah, you're going to throw the ball towards the direction of the moon. The reason is because as you throw that ball, the force that you exert on that ball, you are going to feel equal but opposite. In that case, you are going to move towards the earth. Do you understand? So if you throw this ball upward, you are going to experience equal but a downward force. You understand? And if you throw it towards the earth, you are going to experience equal, but you are going to move towards the moon. You understand what I'm saying? So if you want to move towards the earth, you throw the ball towards the moon. So Newton's third laws of motion tells us that for every action there is equal but opposite reaction. Do you understand? Okay, that's all about Newton's first, second, and third laws of motion. Okay, let's see how we can apply these laws to solve question. Question number 1. A car travels on the road with a constant velocity. Question A. What is the horizontal net force acting on the car? Question B. What is the acceleration of the car? Question C. If the frictional force acting on the car is 1500 Newton, what force is applied to the car by the engine? Okay, let's start with question number 1. We are told to calculate the horizontal net force acting on the car. Okay, now don't forget that the car is traveling at a constant velocity. Okay, that's the first parameter. We have the first parameter here is constant velocity. Okay, constant velocity. Okay, now if an object is traveling in a constant velocity, from our previous explanation, if an object is traveling with a constant velocity, that means there is no change in acceleration. You understand what I'm saying? That is, there is no acceleration. The object is not accelerating. Okay, so an object traveling with a constant velocity, we have an acceleration equals to what? 0 from our previous calculation. Okay, that is under Newton's second laws. Okay, Newton's second law or first law of motion. Okay, so now that means the acceleration is what? 0. Do you understand? So now the horizontal force acting on that car will be what? F multiplied by what? F is equals to the product of mass and acceleration. And since F is equals to ma, a is what? 0. In that case, m multiplied by 0, that is what? 0. That means that the force acting on that car is what? 0. That is 0 Newton. That is, there is no force acting on the car because there is no change in velocity. You understand? The velocity is constant. So for every object which the velocity is constant, the net force is what? 0. Please, it is important that you note that. Okay, now we are asked to calculate the acceleration of the car. In fact, I've already determined the acceleration. The acceleration is 0. How do I know? You know that acceleration is given by what? V minus u over t. You understand? Okay, so now acceleration is what? V minus u. For every object are moving at a constant velocity, that means it's not accelerating. That means the final velocity will be equal to what? The initial velocity. So I'm going to have, let's say maybe the velocity is what? Is moving with a constant velocity of 2 meters per second. That means I'm going to have 2 minus 2. 2 minus 2, that is what? 0. If it's moving with a constant velocity of 4 meters per second, that will be 4 minus 4. So far, we are not told we are not given the velocity which the car is moving. So I'm just going to represent it as what? 0. So 0 over t is what? A is equal to what? 0. Do you understand? Because 0 divided by t, that is 0. Do you understand what I'm saying? So A is 0. So the velocity which the acceleration is what? 0. Now, if the frictional force acting on the car is 1,500 Newton, what force is applied to the car? Now, let me start by asking you this question. What is a frictional force? A frictional force is the force that brings the motion of an object to halt. Frictional force opposes motion. Do you understand? So, let's say the car is moving in this direction. I'm not really good at drawing, okay? Let's say this is the car. Okay, let's say this is the car and it's moving in this direction. So we are told that a frictional force of 1,500 Newton, that is the frictional force that is acting on the car. So therefore, for this object, the force that the engine applies is also 1,500 Newton. 1,500 Newton. You understand? A force of 200 Newton is applied on a 10 kilogram box across a frictionless surface. Question A. What is the acceleration of the box? Question B. If the box accelerates from rest, what will its speed be after 8 seconds? That is, what is the final speed after 8 seconds? Okay. Now, question C. How long will it take the box to reach a speed of 500 meters per second if it continues to accelerate at this rate? Okay. Now, from this question, we've been given that the force is 200 Newton. That is, the force is equal to 200 Newton. That is the first parameter here. The second parameter here is, okay. Now, let's start with the first question. We are told to calculate the acceleration of the box and the mass of the box. We have been given that the mass of the box is 10 kilogram. Okay, 10 kilogram. Okay. Now, let us proceed. Don't forget that force is expressed mathematically as product of mass and acceleration. You understand? And from the Newton's second laws of motion. Okay? And we have been given that the force is what? 200 Newton. So I'm going to have 200 Newton is equals to mass. The mass of the box has also been given. So that is what? 10 kilograms. So I'm going to have 10 kilogram multiplied by A. Do you understand? So to calculate the acceleration will be equals to 200 Newton all over 10 kilogram. Okay, so acceleration is equals to, if you divide this, you're going to get 20. That is 20 meter per second squared. That is the acceleration. Okay, that is the acceleration after the force is being applied. Okay, now let's proceed to the second question. We are told that if the box accelerates from rest, what will its final speed be after 8 seconds? Final speed final speed after 8 seconds. Okay, now I want you to pay attention here. You know, in physics, especially when you are dealing with motion, the concept of speed and velocity are often used interchangeably. Okay, and the relationship between, in our previous class we discussed the relationship between velocity and speed. You know, when we add direction to speed, that means we are talking about the velocity of the object. Okay, and in this context, that's how it is. So for this, the speed here is also the same thing as what? Velocity. Okay, so now don't forget that acceleration is equals to what? Velocity all over time. Okay, acceleration is change in velocity all over change in time. Okay, now we are told that the object accelerates from rest. In that case, okay, let me write it. That will be what? V minus u all over t, tf minus t initial. Okay, so now in this context, we are told that the box accelerates from rest. If the box accelerates from rest, in that case the initial velocity of the ball is what? 0. Do you understand? And the final velocity is what we are told to calculate. Do you understand what I just said now? So the acceleration is equals to v minus 0 all over, and also we are told that the final speed here is what? 8 seconds, and t final is what? 8 minus 0. In that case, acceleration is equals to v over 8. Don't forget that the acceleration that we calculated here is what? 20 meters per second. Do you understand? I mean 20 meters per second squared. So I'm going to substitute the value of acceleration as 20 meters per second squared is equals to v all over 8. Now, if you cross multiply, we're going to have v is equals to what? 20 multiplied by 8. 20 multiplied by 8. So the velocity here will be what? 20 multiplied by 8, that is what? 160. Velocity is in meter per second. So I'm going to have 160 meter per second. So therefore, the final speed of the object is what? 160 meter per second. Okay, let's proceed to the third question. The third question says, how long will it take the box to reach a speed of 500 meters per second if it continues to accelerate at this rate? Okay, now you can look at that question. How long? What are we talking about? How long? That means we are talking about the time. The time taken for the object to reach a speed of 500 meters per second. That is what we are told to calculate. If that object continues, if the box, in this case, continues to accelerate in that rate. Okay? To calculate the time it will take for the box to reach a velocity of 500 meters per second, in that case, the speed of 500 meters per second. Now, if it continues to accelerate at this rate, don't forget that the relationship between acceleration, velocity, and time is this. Acceleration is equals to velocity over time. Do you understand? And we have been given that we have calculated the acceleration as what? 20 meters per second squared. So I'm going to have 20 meters per second squared is equals to velocity, which is the speed. The speed has been given as what? 500 meter per second. Okay, so I'm going to put it there. 500 meter per second all over time. Okay, now let's proceed. For this, I'm going to have time is equals to, that means you are going to cross multiply from this point. So I'm going to have time multiplied by 200. I don't want to show this before, but no, 20 rather. 20 multiplied by time is equals to 500. Okay, so I'm going to divide both sides by 20. Do you understand? I don't want to show this step before, so I just have to show it because I want you to understand this. Okay, so for this, I'm going to have time is equals to, this will cancel this. So I'm going to be left with this 50 divided by 2. That is what? 25. So I'm going to have 25 seconds as the time that it will take the box to reach a velocity, that is a speed of 500 meters per second. Okay, let's proceed to question number 3. A force of 300 Newton is applied across a 20 kilogram box. The frictional force acting on the box is 200 Newton. Question A. What is the net horizontal force on the box? Question B. What is the acceleration of the box? Question C. How far will the box travel after 12 seconds if it continues to accelerate at this rate starting from rest? Okay, let's start by listing out the parameters that we are given in the question. We are given that the force is 300 Newton, the mass is 20 kilogram, and the frictional force of the box, the frictional force acting against the motion of the box is 200 Newton. Okay, let me represent it in diagram. Let's say this is the box. Okay, this is the box. The box is moving along this plane. Okay, this is the frictional force that is acting against the motion of the box. So the frictional force is 200 Newton. Okay, the force, this force that we are given is the applied force. Are you get what I'm saying? That is the applied force. That is the force that keeps the object to move. Are you get what I'm saying? That is the force that makes the object to move. Do you understand? So the applied force is 300 Newton. Okay, now we are told to calculate the horizontal net force. Let me call it H net force, horizontal net force. Okay, we are told to calculate the horizontal net force. Now, don't forget that for an object to move, number one, the applied force must be greater than the frictional force. Do you understand? You know that frictional force is the force that makes an object, that brings the motion of an object to earth. You understand? So for an object to keep moving, the applied force must be greater than the frictional force. Now, to calculate the horizontal net force, the net force will be the difference between the frictional force, the difference between the applied force, which is this, and the frictional force. Do you understand? That is the force which the object is using to move. You understand what I'm saying? That is the force that the object is using to move. After we apply this force, there is another force that acts against the force that we apply. That is 200 Newton. So when we subtract 200 Newton from 300 Newton, the remaining force is what we call the horizontal net force. Do you understand? So the first question, which is the horizontal net force, can be calculated. Horizontal net force, please don't show. Okay, let me just write it in full. The horizontal net force is equals to 300 Newton, that is the applied force, minus the frictional force, that is what, 200 Newton. Okay, 200 Newton. Do you understand? So that is 100 Newton. So do you understand how I got this? The horizontal net force, the net force, is the difference between the applied force and the frictional force. Do you understand? Okay, let us proceed to the second question. We are told to calculate the acceleration of the box. Okay, having known that the force is what, 100 Newton, we can easily determine the acceleration using the second laws, Newton's second laws of motion. Newton's second laws of motion state that the force is the product, the force is equals to the product of the mass and acceleration, and the net force of this object is what, 100 Newton. So we can easily calculate that. That is for question number 2. That is what, acceleration. To determine the acceleration, we are going to use F, which is the force, is equals to the product of mass and acceleration. We have known that the force is what, 100 Newton. So I'm going to have 100 Newton is equals to mass. The mass that we are given in the question is what, 20 kilogram. Do you understand? So I'm going to have 20 kilogram multiplied by the acceleration. Okay, the next thing is that I'm going to divide both sides by 20 kilogram. You understand? So I'm going to have this over 20 and this over 20 kilogram. Okay, then acceleration is equals to, if you divide 100 by 20, that is what, 5. So I'm going to have 5 meters per second squared. Do you understand? So the acceleration of the box is 5 meters per second squared. Don't forget, acceleration tells us how fast the velocity of an object is changing, okay, with respect to time. Okay, question C says, how far will the box travel after 12 seconds if it continues to accelerate at this rate starting from rest? Now, I want to pay attention to the last statement. If the box continues to accelerate at this rate, that is the rate of 5 meters per second squared, how far will it go in 12 seconds starting from rest? In that case, starting from rest means that the initial velocity is what? 0. Do you understand? Please, I want you to pay attention. Now, they said, we are told that let me just put it, question number 3. Starting from rest means that the initial velocity of the box is what? 0. So U is what? 0. Do you understand? Okay? Now, let's proceed. We are told that, we are given that the time if the how far will the box travel? That how far there means that what is the distance that the box will cover? Do you understand? What is the distance that the box will cover if it continues to accelerate at 5 meters per second squared? That is the question. Okay, now we are given that the t, which is time, t is what? 12 seconds. T is 12 seconds. Okay, now don't forget, in our previous class we learned the equation of uniformly accelerated motion. You see now, if you have not, you can revert back to our previous class to learn that equation of uniformly accelerated motion. We are given 4 equations. You understand? Now, out of the 4 equations, which of the equation are we going to use to determine the distance that this box will cover if it continues to accelerate at 5 meters per second squared with at time in 12 seconds? Which of the formula are we going to use? We are going to make use of the third one. Peradventure, if you have not watched the video, you can check the description of this video. You are going to see a link there. Click on that link. You are going to be directed to where you can watch the video. Okay, so let's proceed. So according to one of the equation of uniformly accelerated motion, we have something like S is equals to, S stands for distance, ut plus 1 over 2 at squared. Do you understand? Ut, that is initial velocity, the product of initial velocity and time, plus half the product of acceleration and the square of time. Do you understand? That is what we are going to use to determine how far the box will go in 12 seconds if it continues to accelerate at 5 meters per second squared. Okay, let's proceed. So S is equals to, U is what? 0, because we are told that if the box starts from rest, that is the last statement. So when we are dealing with physics question, especially in motion, make sure you pay attention to the words that was to the sentence. Okay, so for this I'm going to have U, which is 0 multiplied by T, 0 multiplied by 12 plus 1 over 2 multiplied by A is what? 5 meters per second squared. So I'm going to have multiplied by 5 multiplied by 12 squared. Do you understand? Okay, let's proceed. S, which is the distance covered, 0 multiplied by 12, that is 0. Okay, so for this I'm going to have 5 multiplied by 12 squared is what? 144. So I'm going to have 144 all over 2, because this signifies that 1 multiplied by 5 multiplied by 12 squared. If I multiply 1 by 5, I'm still going to have what? 5. You understand? So 5 multiplied by 144 divided by 2. That's how I got that. Okay. Now you can punch your calculator. You're going to get 720. Okay. 5 multiplied by 144. That is 720. So the distance is equals to 720 all over 2. So the distance, if you divide 720 by 2, that is 360. So, and distance is measured in meter, okay, because our acceleration is in what? Meter per second squared. So for this, I'm going to have this. So the distance that the box will cover at time 12 seconds is 360 if it continues to accelerate at 5 meters per second squared. Okay, now let us proceed to the fourth question. A 8 kilogram object speed up from 20 meters per second to 50 meters per second in 6 seconds. A 8 kilogram object speeds up from 20 meters per second to 50 meters per second in 6 seconds. Question A. What is the acceleration? Question B. What is the net horizontal force on the object? Question C. If the frictional force is 35 Newton, what is the applied force on the object? Okay, let's start by writing out the parameters that we are given in the question. Okay, we are given that the mass is 8 kilogram, and we are told that the object speed from 20 meters per second to 50 meters per second. In that case, the initial velocity u is what? 20 meters per second, and the final velocity v is what? 50 meters per second. Do you understand? That is, we are told that the object speed from 20 meters per second, that is from 20, means that initial velocity is what? 20 meters per second, and to 50 meters per second means the final velocity that the object reach is what? 50 meters per second at what? 6 seconds. That is the time taken. Now we are told to determine the acceleration. Okay, what is the equation connecting acceleration, time, velocity, and initial velocity from our uniformly accelerated motion? There is an equation. The first equation is what? V is equals to u plus at. You understand? You can make use of this formula, and you can also make use of this formula. A is equals to what? V minus u all over t. That is, acceleration is equals to change in velocity over time. If you make the final velocity the subject of the relation, you are going to get this equation. Do you understand? Okay, let us proceed. Let's use this. Okay, we have V is what? 50 meters per second. So I'm going to have 50 is equals to u. U is 20 meters per second. So I'm going to have is equals to 20 plus a. A is the parameter that I'm looking for. So I'm going to have plus a multiplied by time. Time is what? 6 seconds. You understand? So I'm going to put 6. You understand? So the next step is that I'm going to make I'm going to collect like terms. Okay, so 50 minus 20 is equals to 6a. That is, the a here is the acceleration. Okay, so 50 minus 20, that is what? 30. So 30 is equals to 6a. Transposition, that is 6a is equals to 30. Divide both sides by 6. You are going to have a is equals to what? 5 meter per second squared. Do you understand how I got this? Okay, having gotten the acceleration of the object, we are told to determine the net horizontal force on the object. Okay, I want to pay attention here. According to Newton's second laws of motion, the net horizontal force is the product of mass and acceleration. Do you understand? Okay, and the net horizontal force, the mass that was given is what? 8 kilograms. So I'm going to have 8 multiplied by the acceleration, that is 5. So 8 multiplied by 5, that is 40 Newton. Okay, so the net horizontal force is what? 40 Newton. Now the third question says we should determine the applied force if the frictional force is 35 Newton. Okay, we want to determine the applied force if the frictional force is 35 Newton. Okay, let me just draw a diagram here. Let's say this is the plane and this is the box. Okay, and the frictional force that is opposing the motion of the box is what? 35 Newton. Okay, are you paying attention? Now we have determined our the net force. Our net force is what? 40 Newton. Don't forget, that is what we calculate. Okay, now we want to determine the applied force. Don't forget, in question number 3, I told you the net force is the sum of, the net force is the difference between the applied force and the frictional force. Do you understand? Please, I want to note that the net force is the difference between the applied force, that is the force that makes the object to change position. That is the applied force, the force that we applied. Now the net force is the difference between this force. Let me call this force x because it's unknown. Okay, the net force is equals to x minus the frictional force. The frictional force is what? 35 Newton. Okay, so the net force, as I've already calculated the net force, that is what? 40 Newton. So 40 is equals to x minus 35 Newton. Okay, so if you connect like times, you are going to have 40 Newton minus 35 Newton is equals to x. Okay, if this negative 35 Newton is crossing the equals to sign, this sign will change to positive. Okay, so this will be what? 75 Newton is equals to x. So the applied force here is what? 75 Newton. 75 Newton. Do you understand how I got this? Just have it at the back of your mind. The net force is the difference between the applied force and the frictional force. Do you understand? So let us proceed to question number 5. An 80 kilogram astronaut in space throws a 2 kilogram box with an acceleration of 4 meters per second squared. A. What force did the astronaut exert on the box? B. What force does the box exert on the astronaut? C. What is the acceleration of the astronaut? Okay, let's start by writing out our parameters. Okay, from the question, we are given that the mass of the astronaut is what? 80 kilogram. Okay, the mass of the box is 2 kilogram. Now, I want to ask you, we are given an acceleration. Is this the acceleration of the astronaut or the acceleration of the box? Of course, this acceleration is the acceleration of the box. Do you understand? From the question, we are made to know that the astronaut throws the 2 kilogram box with an acceleration of 4 meters per second squared. So this acceleration belongs to the board. So I represent it as what? Acceleration AB. Oh, let me change this marker. AB. That is acceleration of the board. Okay, now let us determine the force exact. Let's determine the force that the astronaut exact on the box. Okay, to determine the force that the astronaut exact on the box, we are going to make use of the Newton's second laws of motion, because according to that law, we have F is equals to ma, that is the force applied is equals to the product of mass and acceleration. So I'm going to call this what? Fb, that is the force exact on the box is equals to the mass, which is 2 kilogram. The mass of the box, that is what? 2 kilogram. So 2 kilogram multiplied by the acceleration of the box, that is 4 meters per second squared. Okay, so this will go what? 2 kilogram multiplied by what? 4 meters per second squared. What's the answer? That is 8 Newton. So the force that the astronaut exact on this box is what? 8 Newton. Do you understand? Okay, now that's the first question. The second question says we should determine the force that the box exerts on the astronaut. Okay, according to Newton's third laws of motion, Sir Isaac Newton postulates that for every action there is always equal but opposite reaction. Do you understand? That is, as this astronaut throws this box, that means that astronaut will feel the same but opposite force which he exerts on that box. That's it. Okay, so in that case, the force that the box exerts on the astronaut is what? According to that Newton's law, don't forget, we have something like Fa is equals to what? F minus Fb. Do you understand? So that the Fa here is what? The first force. That is the first force that the astronaut exerts on the box. You understand? Then Fb is the force that the box exerts on the astronaut. In that case, that means 8 Newton is equals to minus 8 Newton. So where minus 8 Newton is the force that the box exerts on the astronaut. Trust you understand that explanation. If you didn't understand, kindly go back to the Newton's third laws of motion that we explained earlier. You are going to understand, okay? So the force that the box exerts on the astronaut is what? Minus 8 Newton. Okay? So let us proceed. For question number 2, that is minus 8 Newton. Now, let's proceed to question C. What is the acceleration of the astronaut? That's very, very simple, okay? Now, we've known that the force of the astronaut is what? Minus negative 8 Newton. The reason why, let me just draw a diagram. Look at this. If this is the astronaut, okay? The astronaut is holding this box in space. He threw this ball with what? 8 Newton. A force of 8 Newton. According to Newton's third laws of motion, the astronaut will exert the same force but opposite direction. That means I'm going to have negative 8 Newton here. You understand what I'm saying? So the astronaut is going to feel the same force which he applied on the box but opposite direction. That is why we have negative 8 Newton as the force that the box exerts on the astronaut. Do you understand? Okay, now to determine the acceleration of the astronaut, don't forget, according to Newton's second laws of motion, F is equals to MA. That is the force, and the force that we have already gotten here for the astronaut is what? Minus 8 Newton. So minus 8 Newton is equals to the mass of the astronaut. The mass of the astronaut from the question is 80 kilograms. So I'm going to have 80 kilograms multiplied by acceleration. Don't forget that the parameters that we are looking for here is the acceleration. Okay, so the next step is that I'm going to divide both sides by what? 80 kilograms. So that means I'm going to have 80 kilograms all over 80 kilograms. So what is the value of acceleration? Acceleration is equals to minus 0.1 meter per second squared. Do you understand? So that is the acceleration of the astronaut. This justifies this statement because the astronaut has an higher mass, so the acceleration is very small. Do you understand? Compared to the acceleration of the box that was thrown in space. Do you understand? So that's it. When the force is kept constant and we increase the mass of the object, the acceleration is what? Is dropped. That is, the acceleration is reduced. You understand what I'm saying? But when the force is kept constant and we reduce the mass, that means the acceleration will increase. Do you understand what I'm saying? So that's it. Okay, let us proceed to the next question. That is question 6. A 120 kilogram skater pushes against an 80 kilogram skater. After contact, the 80 kilogram skater was given an acceleration of 15 meters per second squared. Question A. What is the acceleration of the 120 kilogram skater? Question B. What force was exerted on each skater? Okay, let's start by writing out the parameters that we are given in the question. We are given that the mass of the first skater, that is, let me call it M1. The mass of the first skater is 120 kilogram. That is 120 kilogram. Then from the question, the mass of the second skater, that is called it M2, that is 80 kilogram. Okay. Then we are given that after contact, the 80 kilogram skater was given an acceleration of 15 meters per second squared. That is the acceleration of the second skater. That is what? 15 meters per second squared. Okay, we are told to determine the acceleration of the 120 kilogram skater. Now, I want you to pay attention. Before we can determine the acceleration of the 120 kilogram skater, we have to know its force. You understand? So, and according to the Newton's third laws of motion, that is, for every action, okay, there is always equal but opposite reaction. Do you understand? That is, for every force that is applied on an object, the person that applied the force, the object that applied the force, the man, anybody that applied the force will feel equal but opposite force. Are you get what I'm saying? So I can determine the force. I can determine the force of the 120 kilogram skater from the parameter that was given for the second skater. You understand? I can determine the force of the 120 kilogram skater from the force of the 80 kilogram skater. Do you understand? So let's proceed. Let's calculate the force of the second skater. That is the 80 kilogram skaters. So force is equals to Ma. Don't forget, according to Newton's second laws of motion. Okay. So the force here is what? The mass 80 multiplied by what? 15. So punch your calculator. 80 multiplied by 15. That is 1,200 Newton. So for this, I'm going to have 1,200 Newton. Now, you have known the force that this is F2. Let me call this F2. That is the force that the second skater has. That is the force of the second skater. That is 1,200 Newton. Now, according to the law that I stated earlier, that is the Newton's second laws of the third laws of motion. For every action, there is always an equal but opposite reaction. Just like, maybe let me call this one skaters, the first skaters here, and the skeleton and the second skater. This is their skating space. These skaters exert this force on this object. This skater exerts this force. Exert a force on this skater. So it made this skater to accelerate what? For 15 meters per second squared. Do you understand? This skaters itself will feel the same force that he exerts on this skater. Do you understand? That is all about the Newton's third laws of motion. For every force applied on an object, that object that applied the force will feel the same force, but in opposite direction. Are you getting it? So So F2 here will be what? Negative F1. Do you understand? So since F2 is what? 1200 Newton. So I'm going to have 1200 Newton is equals to what? Minus 1200 Newton. Do you understand? Because according to this is true according to Newton third laws of motion. So the force of the force of the first skater is what? 1200 Newton. Negative 1200 Newton, because I put negative here because it is in opposite direction. Okay, you understand? Please, it is important that you note that the reason why negative is here is because that same skater experience a force that is the same but opposite to the direction of the applied force. Do you understand? So that is why we have negative 1200 Newton. This is 1200. Okay, now we can determine the acceleration of the first of the 120 kilogram skater by using the same law. F is equals to ma. That is F1 now. F1 is what? Negative 200 and negative 1200. So negative 1200 is equals to mass. What is the mass? Mass is what? 120 kilogram. 120 multiplied by A. So I'm going to divide both by 120. Divide by 120. That is A is equals to what? That is negative 10 meter per second squared. Do you understand how I got this? Also, you can make use of this formula because we have been given that M1, we have given the mass. You can make use of this formula. Just M1 F1 is equals to M2 F2. You are still going to get the M1 A1 is equals to M2 A2. That is, the force of the first skater is equals to the force of the second skater. Do you understand? I am very sure you understand that. That is, the force of the first skater is equals to the force of the second skater. But one will carry negative because this one will have negative because it is in opposite direction. Okay? You understand? If you substitute these values, you are going to get A1 as what? Negative 10 meter per second squared. Do you understand? So that's it. It's very, very simple. If you don't understand, pause the video. Reverse the video and watch again. Okay? Let's proceed. Now, for the second question, we are asked to determine the force that was exerted on each skater. We have already determined the force. Even the second question will come before the first. However, you can still solve for the acceleration using this formula. But I just determined to just take you on a long broad so that you are going to understand. Okay? You see, physics is based on understanding. In every calculation subject is based on understanding. If you didn't understand, you won't be able to get your answer. Okay? So you can use this and get your acceleration directly, or you proceed as I did. First, calculate the force of the second skater, which is 80 kg. Then from that force, according to Newton's third laws of motion, every action is equals has an equal but opposite reaction. You are going to get the value of F1, which is the force of the first skater. That is F1. That's why I got there. Then after that, I use the Newton's second laws of motion to calculate the acceleration, and I get negative 10 meter per second squared. Do you understand? Okay, let's do a recap on what we have learned so far in this class. We start from the first Newton laws of motion. The first law states that an object at rest will continue at rest unless acted upon by a force. This implies that there is no change in position of an object that is at rest unless it was acted upon by a force. And the second part in that law states an object in motion will continue in motion unless acted upon by a force. Okay, and I told you, I made you to understand that if an object is at rest, the net force on that object is 0. You understand? And if an object is moving on a constant velocity, the net force on that object is also what? 0. Do you understand? Okay, and the second law states that the force exerted on an object is the product of its mass and acceleration. Do you understand? That is, the force is directly proportional to the mass of the object and the acceleration that the force causes. You understand what I'm saying? And also I need you to understand that if the force is kept constant and we increase the mass of the object, the acceleration will decrease. You understand? And if we decrease the mass of the object while keeping the force constant, that means that the acceleration will increase. And according to the Newton's third laws of motion, for every action there is always equal but opposite reaction. You understand? So make sure you take note of that. See you in the next class. If you like this video, kindly hit the subscribe button and click on the notification bell so that when I drop new video, you are going to get updates. Also, share the video with your friend. See you in the next class.